Welcome to Old Guy Physics again, and we had just finished working on a section on concave mirrors, and now I want to show you the difference with that and a convex mirror. The object is placed in front of the mirror, and so the mirrored surface is on this side, so you see that it's bowing out, and so this is a convex mirror. A couple of places that you see convex mirrors. In the convenience store, you often see them up in the corners of the building, and they kind of give a wide angle view of everything that's going on in the store. Another really interesting place that you see these convex mirrors is on the passenger side mirror of your car. You should look at, next time you look at it, it has a little warning label that says, objects may be closer than they appear. And the reason for that is that on all convex mirrors, the images are actually much smaller than the object that's reflected through them, and our brain sees smaller as being farther away. So when you're driving in your car and you see that image of the car out there on that side mirror, you have to still kind of do that quick look over your shoulder, or you might end up trying to change lanes and the car's much closer than it appears. Now, to get this diagram started, you've got to remember that the two lines that we draw are pretty close to being the same as over there. It's just that the pattern looks a little different. We're going in parallel, and when it strikes the mirror, it's going to reflect. But at what angle? It turns out that the angle that it reflects at corresponds with the focal point, but the focal point is already behind the mirror. In fact, I'm going to put negative signs here to indicate that whatever is behind the mirror is negative and whatever's in front of the mirror is positive. And so line number one shows the light coming in and reflecting off at this angle like that. Now, line number two, this is line number one, line number two, and I'm going to change colors just ever so slightly and see if this will make a difference for you to be able to see it. I found out that if you just draw a straight line from the tip of the arrow straight to the center, that where they intersect right here is going to be the image. Now, as soon as you see that, you'll see that the image is smaller and it's right side up. And it's behind the mirror, so we would expect it to have an image distance that is negative. So let's go through the four characteristics right quick. Number one, it's right side up. If it's right side up, it's virtual. Secondly, you can see that it's smaller and it's located behind the mirror. On all convex mirrors, the images always appear somewhere between the focal point and the back side of the mirror. They will always be there. If the object's farther back, it'll be smaller. If it's closer, it'll be a little bigger, but it's still going to be right in that general area. Now, to show the math that goes along with this, we've got 1 over negative 10 minus 1 over 10, which is the object distance. And that's going to be equal to 1 over di. Now, don't lose this negative sign. You got negative 1/10 minus 1/10 is minus 2/10. When you flip it over, that's going to be negative 5. And if you look, it looks as though, again, I'm not so sure that that's accurate, but right there is approximately negative 5 for the object's position with respect to the back side of the mirror. Now, if there was a difference that I wanted to make sure that you see, we're using the focal point on the back side of the mirror to show the angle of the reflection here. And so we're using the negative 10 as the focal length. If you look at this diagram, which was kind of like the one that we showed where we got an image behind the mirror, we had to use the focal point here to show that reflection off the concave mirror so that we could get an image behind the mirror as well. And so the lines help you to find the image. Now, once we solve for the image, the math should support the diagram and the diagram should support the math. You should see the similarities between, yeah, that looks like that could be -5 and the math came out to -5. If you have any questions, come see me. Thanks for watching.